Database management system. This is the first video of DBMS. So in this video we are going to talk about the core concepts of database. So mainly, what is a database? So database is a collection of data. So your database might be having hundreds of maybe thousands of data. So this set of all the data, or let's say a collection of those data, is known as database. So it is very simple explanation, and these are some example. There has been given some examples for databases. So student data management system is a database, and phone book, Facebook user base, item list. So those kind of components or systems are containing large amount of data. So the set of all data of in a particular system is known as database. Then database approach. So why we need a database? So database is necessary to manage the data, because in some cases there could be having a very large amount of data. So imagine you have let's say hundreds of data. Let's say okay, let's take example like a list of items in a shopping store. So in a shopping store there might be having, let's say, 100 of data. So each of data should be containing can be containing names and expiry date, prices, like that. So it is way more efficient if there is a database to manage those data collection. So that is why we need a database simply to store and manage large amount of data. And yeah, basically database can store in a server or local store. And yeah, there are some example has been given. So these two are the major approaches to the databases. First side is server based, and the second side is local host. Server based mean, we all know, it is a web platform or cloud platform. So take example like Google database. It's a very large and complex database. So it is having multi-millions of data which contain in those databases. So it is a server based database, and users can access through web portals to that database. And in the other hand, there is a database structure called local databases. So we are also going to use local databases, because we can't do server-based databases, because there should be, if we are doing server-based database management, we should be known as other aspects also, like Node.js and SQL, like that. So SQL we know, but Node.js is not Node.js and JavaScript, PHP, those kind of aspects are not related to this series. So we are only looking for this local database management option. So when it comes to local databases, you must be having simple notepad list, but it is way more inefficient. So no one care about it. So imagine you want to manage, let's say, number of names of your friends and their phone numbers. So you might be having hundreds of friends and hundreds or more phone numbers. So imagine, so it's a database, it's basically a database, but it's containing in the notepad. So imagine if you want to let's say if you want to filter out what are the phone numbers that start with 077 extension. So like basically you want to identify what are the dial phone numbers in that particular database. So it is very difficult to identify each of these phone numbers, because we have to go through all of these numbers one by one, and it is on the other hand, it is way more inefficient. So basically we don't use notepad or any other text editors to store or manage our databases. Okay, so next option we have is the local host components. So basically hosting means this server related type of a thing. So basically hosting means your all data segments and application softwares are extending in a cloud platform or store in a cloud based system, which means users and any other administrators that who are interacting with that database should uh, access that server by using let's say internet or any other network facility. But in the other hand, localhost is not using that kind of facility, because we can't afford uh, that much hardware components. So in that case we are just using localhost. Basically localhost mean all your databases and application softwares and uh, all other compilers and SQL servers are stored in your PC. Basically it's a standalone local host. It means your computer is also a server and also a user. That's why it's called as local host. So this local host is basically using for these developing purposes and testing purposes, and it is not it's not for a commercial purpose, because the only user who can access those type of databases or any other local host is only you. So it is basically that's a constraint, which is there should be having only one user. There could be having only one user. But when it comes to SQL and SQL commands, we are only considering one user. Therefore these kind of local host softwares or local host platforms are uh, enough to do our work. So Wamp server 64, and there is a server localhost called Xampp, XAMP. It's also a localhost. So Wamp is also a localhost, and Xampp, in other hand, it's also a localhost. Okay, so basically those are the two types of database approaches. First one is server based approach and the local approach. So in this series we are only going to cover up those local part. Okay, so database environment. So in here there is a simple diagram. So this diagram shows how basic manipulations works on users, servers, and what is this? Servers and DBS, which means database servers. Okay, so in the right hand side there is a sequence of users. So users is start from 1, and it is advancing up until to the user n. So this user n is a finite set, because your server has a maximum capacity. So it might be having it might be having the ability to serve 100 users, maybe million users, maybe multi-million users. So it's depend on the server. However, it's a finite set. It is not infinite, because imagine your server or your corresponding server can give the facilities only to 1,000 people. Then if there are let's say if there are 2000 of people, then server is unable to give the facility to that users in real time. So the system will be compromised, or the server will be crashed, because uh, it has a maximum user capacity. So anyway, in this case it having n amount of users. So in the right hand side there are I have been given 3 databases and 1 server. So the first one is Facebook database, Instagram database, and YouTube database, but this is just a imaginary representation, because in the real world uh, it is not relevant. Anyway, this is how databases and servers are interact. So imagine this user 1 want to access the Facebook database. So the flow will be like this. Say, so the flow will be like this, and imagine user 2 want to access another database. The flow will be like this, and in the other hand okay, so in the other hand let's say okay, so I have done some mistake. So the process will happen like this. First, the user asking for the server to access this Facebook database. So it is just a simple message, and the server will be authorized that access, and it will give the access to this database for the user. So the user 1 will be able to access and manipulate the data which having in this database, which is the Facebook database. So likewise, all other users, all other n finite set users will be able to access each of these databases one at a time, or maybe multiple databases at a time in real time. So that is how basically databases, servers, and users interact with each other components. So in here there are 3 databases and 1 server. So this full system is known as database server. So basically database server means it's a collection of databases and also a server. And this is how database environment this is how we represent the database environment. Okay, so okay, so let's move to the how to create a database. So basically we can create a database by using database languages, and okay, so SQL, MongoDB, MariaDB are the examples for database languages, and those are the most popular database languages that both users and database administrators uses all over the world. So in this series we are going to cover up SQL. So the MongoDB and MariaDB will not be discussed. Only we are focusing for SQL, which is the standard query language. And yeah, let's move to the next part. Okay, so database components. So basically database have entities. Okay, so entities, what is mean by entity? So entity could be a place, or it could be a person, or it could be any other instance. uh, so imagine a student, or let's say school database management system of a school. So there could be having students and teachers, let's say staff, like that. So each other components are entity. We are considering each of these components as entities. So in that case, student is a person and the entity is a person. And suppose an example like let's say a working environment. So in a working environment, there might be having employees, then managers, then we say, let's say, department or branches. So the employees and managers will be persons, person entities. Then department and branches will be place entities, uh, because it represents places, a particular place. So basically, what entity mean is, it could be a person, it could be a place, or it could be any other instance that can be represented as in a database manner. Or let's say that it can be represented as a table or relation. So this entity, maybe you might not heard in this state, but when it comes to entity relationship diagrams or ER diagrams, you will be having a proper uh, knowledge about what this entity means. So it is very important when it comes to database management systems, and when it comes to conceptual side, when you are drawing conceptual schemas, when you are drawing ER diagrams according to the databases, these entities is very necessary. It is essential that you should identify what are the entity means and uh, stuff like that. Okay, so tables or relations. Basically, when it comes to SQL servers or Boolean algebra, or any other database management system, there will be having tables or relations. So, well, we are only talking about relational database management systems. So these tables and relations will be same, but in the relational database management system, this table is known as relations. So actually there is a quite difference between the term table and the term relation. And okay, so let's say table is some kind of a general table, but in other hand relation, it is containing key attributes and other relevant components that should be in a RMDBS or relational database management system. So in this state, it is not necessary to having a idea about what are the tables and relations mean. I will explain this in later. For now, you should have what you should know is, database have entities, and entities could be represent or can be represented by using tables or relations. Okay, so basically entity is a place or person or instance. So each of these persons or places or instances uh, can be represented by using tables or relations. So in a relational database management system, that tables will be known as relations. It's the same aspects, but there is some difference, but it's basically a table. And okay, so rows, columns and attributes are inherited to that table or relations. So you know what are the rows and columns mean. Those are the aspects that we can identify from the tables or relations. Okay, so the relationships, this is the most important fact when it comes to database management systems, because database managing is a term. Okay, so database means normally tables or relations that should be containing independently, but when you are trying to manage each of these tables or each of these data components, each of these tables, or I'll say each of these relations, should be related one another. So in order to make that relation, there will be a term called there will be relationships. So this term, which is the relationships, it is one of the major aspects that we can identify in the database management systems. And okay, and there are three types of relationships. So the first one is one-to-one. It is the most simplest way, and the second one is one-to-many, and the third one is many-to-many. So these type of relationships can be identified from a relational database management system, and I will explain more about relationships in later. So up until now, you should know what are the entity means, what are the table and relation means, and rows, columns and attributes are in the parts, or let's say rows, columns and attributes are the components of the table or relation. And there is also a term called relationship. It's having one-to-one, one-to-many and many-to-many variations, and I will explain more about relationships in later. Okay, I think I might be slow down because now we are going to talk about relations. So it is very important topic. So in here I have been given an example. So it is just a basic table. So it having 4 columns. Okay. So the columns are representing in a vertical manner. Vertical means like this. Columns. You can identify columns like in a vertical aspect or vertical manner. And rows, on the other hand, rows, or let's say records, are in a horizontal manner. So the combination of rows and columns made a table or relation. So the table name I have been given is the student, and there are 4 columns. What are these 4 columns are? Student ID, name. Okay, I have been misspelled this word over here. Okay, so this table contains 4 columns: student ID, name, address and phone number. So basically okay, so what is this attribute mean? So is attribute and column is the same thing? Well, it's kind of same, but attribute means a column that having a specific data type. A column that having specific data type. So in here, student ID, so it might be having a data type like uh, text, or let's say char or varchar. So these terms, char, varchar terms, we will be learning in the SQL. For now, let's say this is a text. This is in text data type or string data type, and this name is also in text data type. Normally, we are not saying these as strings in a database environment. We are just uh, considering these are text values or character values like that. So name is a text data type, and address is also text data type, and phone number is uh, let's say int data type. But also you can consider phone number as text data type, because we are not going to make any calculations by using phone numbers. Therefore uh, phone number might be a string, might be a text, or it could be a int also. Okay, so generally, basically those are the main aspects that we can identify from a table. What are those? Are columns, rows, and attributes. And what is this primary key mean? Okay, so this is also a very important one. So when it comes to database management system, each of our relations containing some kind of a attribute which having unique values. So it is known as primary key. So I will explain more about primary key later. For now, remember, each of our relations that are existing on our corresponding database should be having primary key. If there are, let's say, if there are 4 tables, then there will be having 4 primary keys. Otherwise, it is impossible to make relationships and other stuff by using relations. So for now, just remember, columns, rows, attributes are the parts of a relation, and each relation should be having a primary key. It is necessary. Okay. Okay, so this is the topic what I'm looking for. Keys. So there are 4 major types of keys. So the first one is primary key. The second one is foreign key. And the third one is composite key. The fourth one is candidate key. So basically, these 4 are the major keys that we are need in this series. But there might be having any other keys like super key and compound key and aggregate key. So those are also key components, key attributes, but only we looking for these 4 types of keys, because in the ER diagrams, in the SQL servers, we only need these type of keys. Basically, we are not going to use that candidate key also, because candidate key is just a term. Generally, we are just using primary keys, foreign keys, and composite keys. Okay. Okay. So our first key is primary key. Okay. So first key is primary key. So primary key is an attribute that uniquely identify each records or rows in a table. So I'll just call table or relation. Okay, so I told this before also. So student ID is a primary key in this relation or in this table. So basically what primary key mean is, it is an attribute that has unique values, which means they couldn't contain replicated values or repeated values. So imagine, let's say address. So address is not a primary key attribute, or let's say address is uh, not good to consider as a primary key, and it can be considered as a primary key because it having replicated or repeated values. So New York uh, has been repeated, therefore this attribute can't be identified as a primary key. So what about name? Is name is a good attribute for primary key? Well, in this case, you might be identify each of these values. Okay, each of these values in name attribute as unique, but this attribute can't be identified as a primary key because okay, so in this state, Ross, Chandler, Walter, Jesse, Michael are unique values in this table, but when it comes to general world, or let's say in a practical situation, a practical scenario, there must be having two persons that have the same name, or there must be having uh, more people that having the exact same name. So if we identified name as a primary key, then when a person, when let's say when it comes a person who have the same name, exact same name, then there will be a problem. So maybe our database system uh, will not be able to identify that person because we already has been initialized name as a primary key. If we already has been initialized name as a primary key, then if there is a person who came, let's say a person named Walt again came, so the system won't be able to store that value because primary key should be in a unique state. So that type of a person could be able to access, or let's say could be able to store its own values in this table. So that's why we can't initialize name as a primary key. So then we have two options left. So I'll move the phone number. So is phone number is phone number is a good, or let's say proper attribute as a primary key? Well, phone number is normally not repeating. When it comes to general world, uh, there can't be existing exact same name, exact same phone number for two persons. So you might be thinking phone number is a good attribute for primary key, but it is not, and this is the reason. Uh, so in this state, it says the primary key is an attribute that identifies each records in a table uniquely, but the unique is not uh, the uniqueness is not the only aspect that should consider primary key. So then other aspect is orderly manner. So what is this orderly manner mean? So imagine this phone number as a primary key. Then our primary key will be unique. It's okay, but it's not in an orderly manner. Like it is starting with this number, then there will be this number and this number, like that. There will be a random phone numbers, or there will be some random values for this attribute. So it's unique, but it's random. It's not in an orderly manner. But what about student ID? So student ID is a attribute that having unique values. It's okay. Then it's also in an orderly manner. So just look up this field. So it start from S001, then S002, and it is increasing up until to the S005. So it is in a proper orderly manner. So when you are initializing primary key, it is better if that corresponding attribute having orderly manner and a uniqueness. Okay, that's why I told phone number is not a good attribute for a primary key. And there are some other attributes also. Let's say NIC and driver ID. So those are also unique, but they are not in a orderly manner. So we can't, well, we can use those type of attributes as primary key, but it is not a good way to initialize a primary key. So always remember, when you are initializing primary key, that corresponding, or let's say that particular attribute should be in a orderly manner and it should be unique. And that's about primary key. Okay, type of primary keys. So there are two types of primary keys. First one is surrogate key and second one is natural key. So surrogate key means, surrogate key is just a unique identifier as a primary key, and it is only existing in a database environment and there is no natural existence. So what this means is, so imagine this table. So I'll move to previous slide. Okay, so in this table, student ID is not existing in a real world aspect because in the database administrators, or we just created a new attribute for initialize each of our elements that containing in a table uniquely. So this is a one attribute we created for our database managing purposes. So it is only existing on the database. There is no physical existence. Okay, but in the other hand, phone number, or let's say NIC or driver ID, there is a physical existence. Normally in the real world, we can find a phone number, we can find an NIC, we can find a driver ID. So those type of things having physical existence, but as I told before, they are not in an orderly manner. So it is not good to initialize those kind of attributes as primary keys. Okay, so let's move to our current slide. So the surrogate key means it is only existing on the database. There is no any physical existence. So what about natural key? So natural key is just also unique identifier as a primary key, but it is existing in a database environment and also it has a natural existence. That's why I told that thing before. If you initialized NIC or license ID as a primary key component or primary key attribute, those are natural keys. Those are actually existing in a real world aspect, but when it comes to database management systems, it is not a proper way to initialize the primary key. So maybe in a let's say when we are considering the whole country as a database, it is way more complex. Then the primary key should be a NIC, because each of all of the persons have NICs. So all the NIC numbers are unique, and when you are considering all the country, or let's say a big amount of database, then we can consider NIC as a orderly manner. But normally we are not going to build that much type of a complex database. Therefore, it is not a good way to identify natural key as a primary key. So what I wanted to tell is, we are using this surrogate key type as a primary key, because that is the only way we have to identify each of attributes in a uniquely and orderly manner. Okay, so this is the basic aspects for primary key. Okay, so then foreign key. So this is the second type of a key attribute. So it's a field in the table that is a primary key of another table, and this is another most important key attribute that we can identify in a relational database management system, because I told that one before, in the relational database management there are existing relationships. That's why we are calling it as a relational database management system. So in order to make relationships, we have to use key values in relevant tables. So in order to make relationships, we are using this foreign key as a key attribute. Okay, so in here I have been given some example. So imagine this is our first table, which is the employee table, and this is the second table, which is the manager table. So employee table having employee ID, employee name and phone number as its own attributes, and manager ID, employee ID and M name branches are the attributes of manager entity or manager relation. So when we are considering employee table, primary key is employee ID, because it's the attribute that can identify each of these elements uniquely. And in the other hand, manager ID is the primary key of manager relation, because it is the unique attribute. So so when we are making relationships in between these tables, what we are going to do is, we are taking a primary key of a table and we are putting that primary key to another table. So this is a primary key of this table, but when it comes to this table, this is not a primary key, it's a foreign key. So foreign key means basically a primary key of another table. It's not the primary key of this table, but it's a primary key of another table. So in this case, manager, in manager relation, employee ID is the foreign key, and in the employee table, employee ID is the primary key. So that is the main difference between primary key and foreign key, and only difference between primary key and foreign key. What the difference is, foreign key is also a primary key, but it's in another table. It's not in this current table. So imagine now we have been initialized our foreign key So imagine we have been initialized our foreign key as employee ID. So in here now E001, E001, E003 and E004 are the data values, and E001 and E001 is repeated. So is it wrong or not? Wrong or correct? Well, there is nothing wrong with it because this is just a foreign key, and I said primary key is the one that should contain unique values. So I never said foreign key should be containing unique values. Okay, so unique key is a primary key of another table, but in this state it is not a primary key. So there should be having replicated values, and it is not wrong. And in other hand, manager ID is a primary key, so it shouldn't be repeated. If it is repeated, then it is wrong. The primary key is the only key attribute that should not be repeated in a relevant table. So employee ID could be repeated, and it's a foreign key. Okay, so what is this line mean between these tables? So you might not be notice this notation also, and well, this is the most important notation when it comes to ER diagrams. So when you are learning entity relationships diagrams, ER diagrams, you will be considering relationships in between tables. So in order to make those relationships, each of relations or each of tables in your database management system or database should be mapped for one another. That's why I put this notation here. So as I told you before, when we are making a foreign key, it's automatically making a relationship between two tables. So imagine we have three tables like this. So I imagine this table as, let's say, department. So and imagine its primary key is the dep ID. Sorry. So dep ID is the primary key of this relation. So if we want to relate this table also, then the only way to make that relationship is to initialize this dep ID as a foreign key in this table or this table. So maybe this dep ID will be mapped over here like this, might be, or maybe it could be mapped like this. So what I'm telling, it as a might be, because it's depend on the context. So I can't exactly say this will be mapped over here or over here. It's depend on the context. So when we are doing our requirement analysis, it's a you will be learned that one in the system analysis or system designing, there is a life cycle called the life cycle of a database, life cycle of a system. So the first topic is requirement analysis, then database design. So this is the database designing, which is the conceptual schema. So I will be teach those things in later. So this is in the second step of that life cycle. So in the first step, which is the requirement analysis, in that state, we identify these kind of scenarios. Like this. So in here we can't guarantee if it is mapped like this or mapped like this. So in the requirement analysis, we can identify what will be mapped with what will be exactly mapped. Okay. So basically this is how mapping works. Mapping is basically making relationships in between tables. If we make relationships in between table, then there will be a relatable or related databases. Then that whole collection will be known as relation database management system. So that is how RNDBs are made, and by using these foreign keys we can create or we can access relationships in between tables, and that's how foreign key works. Okay, so let's move to the next slide. So relationship is a thing that existing on between tables. So in here there is a relationship in between employee table and manager table, or employee relation and manager relations. And in relational DBMS, this table is a relation. I told this thing before. Okay, so the next topic is next point is, okay, so because of this relationship we can access each related attributes in a one table or relation to another. Okay, so this is another important thing when it comes to databases. Okay, so imagine, I will just quickly erase those things. Okay, so imagine we haven't mapped these two tables. So what will be the attributes? Then the employee table will be having these attributes as the default state. But what happened to the manager table is there will not be existing employee ID, because employee ID is a foreign key that we have been initialized in order to make a relationship in between employee table and manager table. So if in the initial state there is no relationship in between these tables, so employee ID will not be existing in this manager table. Okay, so the manager table attributes will be manager ID, manager name and branch. So imagine a scenario like when a person or a user want to identify what are the employees who are managed by Michael. So the Michael is a manager, and John, Oliver, Winston and Noel, John are the employees. So if a user want to identify what are the related employees to the Michael, then there should be containing this attribute. Otherwise it is impossible to find, because in the initial state I told that as I told, in the initial state this mapping is not existing, which means this attribute is not existing. So the only existing attributes will be manager ID and manager name and branch. So when a user want to find an employee who related to Michael, it is impossible to identify that because this employee ID is not existing, and that is why we are making relationship in between tables. Okay? So if we made a relationship like this, then employees are existing on this table, then we can identify who are the employees related to Michael by accessing only this manager table. Okay, so that's how relationships are works. And okay, so that is what I told before. So imagine we want to query who are the employees that are assigned to Michael. Then there should be a relationship in between employees and manager, like I explained before. In order to build a relationship or relations, we should assign proper foreign key to the manager. So in this case, our foreign key is the employee ID. So in order to make the relationship in between these tables, there should be this foreign key. And now we can access employee relation by using manager relation, like I explained before. And that is all about foreign keys. Okay, so entity relationship diagrams. So this is just an introduction. So here diagram shows how the relationships are made in between relations. So this is just an example. So this is our first table, employee table, and this is our manager table, and this is a notation called the relationship, and employee assigned to manager. This is the relationship in what existing on these two tables, and you will see about these type of things in later. For now, it is not necessary to go more in detail. Okay, so the next thing is composite key. Okay, so this is also important. The composite keys is a combination of non-key attributes that can identify each record in a table uniquely. Okay, so the basically composite key is a collection of attributes. Maybe those could be key attributes, or maybe just normal attributes. So imagine this is our table. So our first attribute, the game name. So there are some values like code NFS, code GT, and this is not a unique attribute, and this is not in a orderly manner. So it's just an normal attribute. Then what if extended name? So MW, MW, BO, B is also just random values. Those are not existing like in uniquely manner. But as I told before, when it comes to relational database management systems, it is necessary to having a primary key for a relation. So how we made a primary key for this relation? So first option is we can made a surrogate key. So surrogate key means we are defining a new attribute in a table. So like maybe we could define a let's say maybe we could define a attribute field like game ID. So G001, G002, G003, G004. Likewise, we can define a surrogate key for this relation or table. So it is also okay, but there is also another option, which is the composite key. So composite key is combine two attributes in order to make a complete unique set. So imagine game name and extended name is the composite key. So these attributes are combined together. Then code MW will be a one data part, will be considered as a one data part. So the code MW, NFS MW, code BO, GTA5, those are unique. Now those are in a unique manner, but still they are not in a orderly manner. But imagine there are some constraints like our database only allowing to create the existing attributes. So in that kind of a scenario, we can't make a surrogate key like this. So the only options will be the composite key. That is why we are using these two attributes as a composite key in order to make a primary key. Okay. So this is what I explained before. Is there any primary key? No, there is not a primary key. Then how we define a primary key? So only option will be we can combine two or more attributes and then build the primary key, just like this. Now we have a primary key and it's a composite key. So now each of these elements are unique, but still not in orderly manner, but these are unique. So it can be considered as a primary key. It's not a good way, but it can be considered as a primary key. So now we have a primary key and it's a composite key. And that is all about composite key. Okay, so the last one will be candidate keys. So what is the candidate key mean? Candidate key is a tuple that uniquely identify each records in a relation. So this tuple means a collection of attributes, right? So basically candidate key could be a primary key. Okay, candidate key could be any other key attribute. So in this case, imagine this is our relation. So as I explained before, student ID and phone number is the valid key attribute, not primary key attribute but key attribute, because they are containing unique values. And candidate key means well, these are the candidate keys. If there are existing any key attribute in a table, those are candidate keys. So basically primary key and foreign key are chosen from those candidate keys. So likewise foreign key may be also a primary key in another table. So in that table this is also a candidate key, because candidate key is the whole set of a relation that consisting all the key attributes. So the primary key is also a key attribute, so the primary key will be chosen from that candidate key group. And when you are making relationship in between tables, so that corresponding primary key will be a foreign key. So when we are considering this backward manner, the foreign key is a primary key of another table and that primary key is a candidate key. So that's how foreign key becomes a candidate key. And basically those are the 4 major types of keys that you should know when it comes to database management systems. Okay, So the summary, what we have learned so far. So we first we looked what database means. Then we saw that database mean is a collection of data, and shop list or item list, phone book, or uh, Facebook user base are the valid databases. And database approach, we talk about database approach. So there are two types of approach that we have been taught. First approach is server-based approach, and the second type is local host. So the server-based approach means basically a web-based system, and the local approach means basically it is existing on a standalone manner. It is existing on your PC or laptop or like that. It's existing on the local space. So those are the two approaches in database. Then we look for the database components. So in that topic, I told what is the entity means, then what is the relation means, table, rows, columns, then attributes and relationships. So basically entity means it could be a person, place, or maybe an incident. So when you are considering school as a database management system, student, teacher are the persons and they are entities. When we are considering department or working space as a database management system, there could be having employees and managers and maybe branches. So those are entities, and managers and employees are person entities, and that branch or department are place entities. And tables relations is the same thing, but there's quite different in between relations and tables, and I told that one also. And relationships, so there are three types of relationships. First one is one to one, then one to many, then into many. So those are the basically components of a database. Then we looked what is the table and relation means. Basically table and relations is the same thing, but when it comes to relational database management systems, that tables become a relations because that table consisting of key attribute, or if we more specified, that table consisting of primary key. So it's become a relation instead of just a table. So that's the tables and relations. And when we talk about keys, so there are four major types of keys. First one is primary key, then foreign key, then candidate key, then composite key. Primary key, foreign key, composite key, and candidate key. And there might be having any other key types also, like super key and aggregate key. Then we talk about primary keys. So primary key is basically a unique identifier which in an orderly manner in a table that can identify each of the records uniquely. So that is what primary key means. And there are two types of primary keys. The first one is surrogate key, which means there is no physical existence as a key attribute, and the second one is natural key, which means it has a existence in a real world in a general manner. Then we came foreign keys. So foreign keys are basically a primary key of another table, and we use foreign key in order to make relationships in between tables. So when foreign key made, there will be also a relationship. Okay, so that's how foreign key works. And we came composite key. So composite key mean is also a key attribute, which consisting two or more attributes in order to make a one key attribute. So that composite key might be a primary key. Well, it should be in a uniquely manner, but we can't guarantee it's only orderly manner. But if there is only option, we can consider that composite key as a primary key. And the composite key means it's a collection of attributes in order to make a one unique attribute. Then we came to candidate keys. So candidate key means basically a key attributes or a tuple of key attributes, which means a set of key attributes. So these three type of keys, primary keys, foreign keys, and composite keys are chosen from this candidate key. But maybe this composite key is not in candidate key, because in sometimes composite key might contain just a normal attributes. So normal attributes is not key attributes, then they are not candidate keys. So composite key might be a candidate key or may not be, but primary key and foreign key for sure it will be a candidate key also. And that's all what we have learned in this episode. Yeah, it's all for now, and next episode we will looking for SQL commands and their uses.